Hi everyone, this is Ms. Drake. In this lesson we'll be finding solutions to quadratic functions by factoring. So if you're in my class, that'll be lesson number 63 in your Unit 6 packet. Okay, so you go through the do now, your answers are here, and we're going to move down to our first example, which is a quadratic equation. So we have our first equation right here, and what makes this a quadratic is that it has an x squared. So when you have an equation with an x squared, your steps for solving are different than they would be if you just had an x to the first power. Okay, so what we need to know is that standard form is ax squared plus bx plus c equals 0. So whenever we solve, if our equation is not in that form, we want to get it into that form first. So that's really our first step, to move all the terms to the same side of the equal sign. So here I just have this 5 on the right-hand side. I'm going to move it by subtracting it from this side. And then if I can subtract from any like terms over here, I will. Otherwise, it'll just go at the end. So I'm going to put it underneath the plus 15. Okay, so here we cancel, and I have x squared plus 7x plus 10 is equal to 0. So step 2 says to set the equation equal to 0, but I did that by doing the 5 minus 5. Okay, so now I am ready to solve by factoring. So I'm going to do this third step is factor the algebraic expression, so that's this trinomial on the left-hand side. So you have to think back to last unit when you were factoring trinomials. You're just going to ignore this equals 0 for a second. It's a trinomial with a leading coefficient of 1, or a is equal to 1. So you should think double bubble, or 2 sets of parentheses, and since a is 1, you know the only things that can go here are x and x. And then to figure out the two constants, you have to do a factor sum table. So we want factors of a times c with a sum of b. So remember, a is 1, b is 7, and c is 10. So I want factors of a times c, so 1 times 10, so factors of 10, two numbers that multiply to 10, with a sum of b, or a sum of 7, so two numbers that add to 7. So what I like to do is list my factors of 10 and see which ones add up to 7. So factors of 10 are 1 times 10. Well, let's see, is 1 plus 10 equal to 7? No, that's equal to 11, so cross that off. How about the next factor pair of 10 would be 2 times 5. So then we'll test 2 plus 5, is that equal to 7? Yes, it is, so that is my perfect pair. So I'm going to put plus 2 here and plus 5 here, since these are both positive numbers. Okay? So our next step is to take each of those factors and set them equal to 0. What we're doing here is called the zero product law. It's saying if a times b is equal to 0, then either a is 0 or b is 0. So if this times this is equal to 0, then one or both of them have to be equal to 0. So I'm going to set each factor equal to 0. So x plus 2 equals 0, and x plus 5 equals 0. Now I have two one-step equations. The exponent of 2 is gone, and I can solve each one to get my two different solutions to this equation. So I'm going to solve this one first. To get x by itself, I need to undo plus 2. So I want to do the opposite of addition. What's the opposite of addition? Subtraction. So I'm going to subtract 2 from both sides, and I have x is equal to negative 2. Now I'm going to solve this equation. X plus 5 is equal to 0, so I'm going to subtract 5 from both sides. Right, that's the opposite of addition, and I have x is equal to negative 5. Okay. So unlike linear equations, which we solved at the beginning of the year, when we have a quadratic equation, we can have two different values that make the original equation true. Okay, so what this is saying that negative 2 makes this original equation true, and negative 5 also makes the equation true. If you want to check it, you can always check, okay, by substituting the values into your original equation. So let's check negative 2. So we're saying that negative 2 squared plus 7 times negative 2 plus 15 is equal to 5. Right, so I'm taking that answer and I'm substituting it into the original equation. If you plug this whole thing into your calculator on Desmos, you should get 5. So that checks. There's two solutions, because if you plug in negative 5, that will also make the equation true. So you do negative 5 squared plus 7 times negative 5 plus 15, and you should also get 5. So if you type this into your calculator, you're going to get 5. Okay, so the quadratic equations, sometimes we have two values that make the equation true. Okay, so what I want you to do is turn the page and try example 2. I'm going to pause the video, and when you're done, unpause and check your answer. Okay, here we go. I got the equation set equal to 0 to get this trinomial. I factored the trinomial into n minus 4 and n minus 6. So when I solved the two one-step equations, I got n equals 4 and n equals 6. So I wrote that answer over here. Okay, so now we're going to skip down to example 5, where we may have a GCF in our trinomial before we have to factor. So the process is still the same, where you want to get the equation set equal to 0. So I'm going to do that. I'm going to subtract 6 from both sides. So I have 6n squared minus 18n, and then negative 18 minus 6 is minus 24. So now the equation is set equal to 0. So I still want to factor the left-hand side. So before I do that, see how a is not 1, a is 6. So before I try to factor the trinomial, I'm going to check to see if there's a GCF first. So I'm going to look at my 3 coefficients and see if there's a number that would divide all 3 of those numbers. Okay, and hopefully you came up with the number 6. So I'm going to divide all 3 terms by 6. I'm going to put that on the outside of my parentheses. Okay, this should be review, hopefully, from the last unit. 6n squared divided by 6 is n squared. Negative 18n divided by 6 is negative 3n. And negative 24 divided by 6 is negative 4. Okay, so now I'm going to take this trinomial inside the parentheses, and I'm going to try to factor that. So it should be a little bit easier now that the new a value is 1 instead of a 6. It's easier to factor when a is 1. Okay, so I'm going to bring down that GCF of 6, and then I'm going to go into my double bubble. Since this is an n, I know that both of the first variables are n. And then I have to figure out what numbers go here and here. So I set up my factor and sum table. So I need factors of a times c with the sum of b. So a is 1, b is negative 3, and c is negative 4. So a times c is 1 times negative 4. I want factors of negative 4 with a sum of b, so negative 3. So what that means is that I'm looking for 2 numbers that multiply to negative 4 and add to negative 3. So think of your factors of negative 4. You could either have 1 times 4, or, negative 1 times 4, or 1 times negative 4, or you could do 2 times negative 2. Okay, so check by adding all 3 of those to see which ones add up to negative 3. Okay, so if I add negative 1 plus 4, do I get negative 3? Nope, I get positive 3, so that doesn't work. If I do 1 plus negative 4, I should get negative 3, so that's going to be my perfect pair. If I add these 2 together, I would get 0. But once you find your perfect pair, you don't really have to keep checking. So I have a positive 1, so n plus 1, and a negative 4, so n minus 4. If you had put them in the other order, that would have been fine too. Okay, so now I have 3 factors to set equal to 0. So the GCF, 6 equals 0. Is that true? Nope, that's false. I can just throw that out. So the GCF just gets thrown out. I'm going to set this factor equal to 0, n plus 1 equals 0. And then I'll set this factor equal to 0, n minus 4 equals 0. So now I have 2 one-step equations I can solve to find my 2 different values of n. So I'm going to solve this one. I have n plus 1, so I'm going to do the opposite of addition, which is subtraction. I'm going to subtract 1 from both sides. And n is equal to 0 minus 1, which is negative 1. Okay, now I'm going to solve this one. Okay, it's n minus 4, so I have to undo that subtraction with the opposite, which is addition. So I'm going to add 4 to both sides and get n equals 4. So I have 2 solutions again. N equals negative 1 and n equals 4. Okay, I could plug those into the original equation to check to see if it makes the equation true. Okay, so try the rest of the practice questions and then do the homework questions. Let me know if you have any questions at all. Have a great day.